Hello everyone. Welcome to our final project presentation for Introduction to Artificial Intelligence at the University of New Haven. Our project is titled TicTacToe AI Agent using Minimax and Alpha-Beta Pruning. I am Haley Sureja and my teammate is Priyanka Singh. We collaborated on the AI logic, code development and performance testing. Our goal was to create an AI agent that can never lose in tic-tac-toe. It plays optimally and evaluates the best possible moves. We used the Minimax algorithm for decision making and improved its performance using alpha-beta pruning. The game is built in Python using Pygame. The objective was to implement a smart agent that efficiently plays and wins. We wanted to reduce unnecessary computations and analyze performance against both random bots and human players. Tools and technologies used were Pygame for the game inference, Python for the core logic, the random module to simulate a basic bot, and a time module to measure AI response time. What is Minimax algorithm? It is a decision-making algorithm used in two-player games. It assumes the opponent plays optimally and chooses moves that minimax potential loss while maximizing the AI's gain. It results in perfect play, either a win or a draw. What is alpha-beta pruning? Alpha-beta pruning improves minimax by cutting off unneeded branches. This means faster AI responses without changing the outcomes. Research questions and methodology. Our core question was, can AI agent using Minimax with alpha-beta pruning outperform random or human players? We represented all possible games moves using a tree, applied Minimax, optimized it with pruning, and tested it. This is the workflow of our project. Tom is X, Cherry AI is O. So our artificial agent is O. First, the Tom makes a move. Cherry calculates the best possible move. Cherry, that is our AI agent, uses Minimax alpha-beta pruning to quickly find the optimal move. Game continues until there's a win or a draw.
Our code is modular. Main.py runs the game. Game.py manages GUI. AI.py contains the smart AI logic with pruning. AI simple is used for benchmarking, and randombot.py plays random moves. We evaluated the AI using these metrics: win rate against random bots, optimality as it never loses, efficiency from pruning, and user feedback about the AI's behavior. In our demo, you will see how the AI responds instantly after the players move. It evaluates all possible options and selects the most optimal one. Some challenges we faced were building a recursive minimax without logic errors, handling Pygame events responsively, and balancing speed with pruning. We learned about adversarial search, how pruning improves AI, modular coding, testing logic, and solving game state challenges through smart decision trees. These are the conclusion. Successfully built an intelligent tic-tac-toe agent that never loses. In the future, we aim to expand the AI to larger boards, enhance the GUI with libraries like Tkinter, enable multiplayer functionality, and experiment with reinforcement learning for adaptive gameplay. Now I will hand it over to Heli, who will walk us through the demo and explain how the AI works in action.
I will walk you through the demo part. This is our GitHub repository, TicTacToe AI Project. It has all the files and folders used for the project. This is the README file, which is TicTacToe AI agent with Minimax and alpha-beta pruning. This is the project goal, introduction, AI techniques like algorithms used. This is the tech stack, that is tools and technologies used. This is the file breakdown, which files are used and what it does. This is how to run the game, evaluation criteria, demo video, future ideas. This is all the thing which is already explained in the presentation part. Now I will walk you through the code part. So here is my editor and see. Here is the TicTacToe AI project folder, which has subfolders and the files which are used to run the game. So this is the assets folder, which has Jerry and Tom. These are the images which are used in our game instead of X and O. It's to make more funnier and like attractive. Now, this is the AI sample file. This is the file where the normal AI code is written. Like if we are playing against an AI agent, then human can also win. The algorithms are not implemented over here. This is the AI file. So this is the file where the algorithms are applied. So let's break it down. This is the best move method. Now what happens here is this scans the entire board and checks each empty spot. For every possible move, it temporarily places an O, that's the AI symbol, and then calls the Minimax function to evaluate how good that move is. After testing all moves, it picks the one with the highest score. Now this is the Minimax method. What happens here is this is a recursive algorithm. It simulates all possible future moves until the game reaches an end. That is either a win, a loss, or a draw. So this is done over here. Then when its AI is done, that is max is true. Then it tries to maximize the score by picking the best option. And then when it's the human's turn, where the is max is false, it assumes the human plays perfectly and tries to minimize the score. Alpha-beta pruning is also done here. Now, to make things faster, I use two variables, alpha and beta. This helps to cut off branches in the game tree that don't need to be explored because we know they won't affect the final outcome. This makes the AI much more efficient. So here, the minimax with alpha-beta pruning is applied, and this is done in the coding part. Now, this is the check winner method. It checks rows, columns, and diagonals to see if anyone has won or if the game is a draw. Now, this is the game.py file. Now, here we have done import py game. Then here it is the init method. Now, what happens here is we set up the game window. The game window has been set up using Pygame. The board is 3x3 grid. Normally, we are using 3x3. So it's like stored as a list of list. We load two images. Tom's image is player X and Jairus' image is like O, which is our AI agent. See, these images are taken from this assets folder, which I showed you earlier. So this is how it's done. Then these images are resized to fit nicely inside each cell using Pygame transform.scale. So this part is done over here. The next part is draw board. We clear the screen here. Screen is cleared and draw the grid lines to create a 3x3 board. We loop through each cell. Each cell is looped and in the cell contains X, we draw Tom's image. And the cell that contains O, we draw Jairus' image. The images are placed with slight offsets to center them nicely in each square. This part is done here. Okay. And then the game loop, the run method. It's here, the run method. So this is the main loop. Now it checks for the mouse clicks when it's the human player's turn. Updates the board when a player clicks a square. When it's the AI's turn, it calls the AI's best move method to make a move automatically. The best move method is called here. After every move, it checks if there is a winner, if the game is draw. Checking the winner. So here at last, the winner is checked. This is the method. Now the check winner method looks at all the rows, columns, and diagonals to see if a player has won. What happens if the rows, columns, and diagonal has all three same, either Tom or Jerry, then it wins. If all the cells are filled and no winner is found, it returns a draw. This is the main logic. Now let me tell you summary of these files. I already told about AI simple and AI game.py. The main.py is the main file that starts the game and initializes the AI. The random board is the file where the simple board that plays the random moves are played over here. Now, if in the main file, instead of AI simple, this is AI simple. If we run this file, then here, this logic will run so that human can also win. But if we are writing here AI.ai, this file will run and we will not win. So let me run the file, show you. This is first, let me show you what I did earlier. See, this is the Pygame. I need to install the Pygame to run this all the files. Then this is I run all the file. Now this is, let's do Python main.py. For now, in the main file, it's AI simple. So we can win. Okay, Control S. Sorry for that. Okay, we will write Python main.py. Yes, yeah, this is the pop-up window. Now it's our turn. First we play. This is Tom. Let's hope we win. Yeah, see, this is win. We win the game. Winner is X, that is us. So it's AI simple. So yes, we can win now. But if we are writing just AI, that is our algorithm, that is the file where we use to run our algorithm. Let's save it and run it again. Yeah, if we are running it again, I will play the game for 3 times because it's the demo one, and we know that we are not gonna win with this thing because it's the AI agent which use Minimax and Alpha-Beta Pruning. So this here, 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 here. So it's draw. Mostly the draw happens here. The agent is built in such a way that is not allowing a human player to win. So here I'm playing for 3 times. Let's see what happens. Okay, here winner is O. So here the AI agent won. Last time, let's see. Okay. Chong, here. Okay. Winner is O. So this is how our game is implemented. Thank you friends for watching us. This is our email ID. If you have any questions, feel free to reach us. This is our GitHub link. You can clone the code and play the game. We would also like to thank Professor Shivanjali Khare, who was there to help us throughout the project.